girls, we are doing another lab today for our motion stations. Today we are doing our lab that is station 2, changing forces. So our question is, how does the distance that a car is pulled back affect the distance it travels once it's released? So our plan, we are going to pull back a toy car 3 times, each time pulling it back a little bit farther, and you will measure how far that toy car travels. For this, you will need a flat surface, so I'm working on the floor. You'll need a ruler or like a measuring tape. You're gonna need a tape, pieces of tape or something to mark where your starting line is. And you're gonna need a car that when you pull back, it moves, okay? It's different than a Matchbox car. If you don't have one of these, that's okay. I'm going to do a demonstration for you and you can use my data. That will be in a different video later on, so you'll have to find that in the assignment, okay? So I'm going to show you what you're going to do if you have one of these. What you're going to do is you're going to complete the data table, and the first thing in our data table says trial 1, and this is how far you've pulled back the car. So what we're going to do is we're going to use this as the starting line, okay? This will be where the edge of the car has to be, and the first one, I want us to start at 1 centimeter. So what we're going to do is we're going to line up the car here, okay? And I'm just going to pull it back. See how I have lined up 1 centimeter to the beginning? I'm going to line up the front of the car to the front of the ruler, and I'm going to pull the car back until the front of the car touches the edge of this line, okay? So just the 1 centimeter. It's not very far at all. So I'm going to pull it back, and then I'm going to let it go. And you can see that it moved a little bit. Now I'm going to write in my table 1 centimeter because that's how far I pulled it back. I need to now measure how far it traveled. So what I will do is I'll use my ruler and I'm going to measure from that line, the edge, all the way to the end of our car. And this one was about 8.5 centimeters. So I would write 1 centimeter here, 8.5 centimeters here. The next time, instead of just pulling it back 1 centimeter, we're going to pull it back 3 centimeters. So see how I've lined up the 3? Now I'm going to put the front of the car at the front of the ruler, and I'm going to pull it back until it gets to this edge. Pull it back and let it go. So this time you see it went a little bit further. Now I'm going to measure that distance. I'll write 3 centimeters, and then when I measure it, I'll write the measurement here. The last one, we're going to pull it back 8 centimeters and then let the car go. So you'll write 8 and then you'll let the car go. You'll measure how far it traveled and you'll write that number in centimeters. Once you have done that, you are going to answer the questions below. The questions below say, what pattern did you notice in the distance the car toy was pulled back and the distance it traveled when it was released? So the farther the toy car was pulled back, the more you pulled it back, the what? Was it the shorter the car moved or the longer the car moved? So if you pulled it back more, did it travel a short distance or a longer distance? What do you predict would happen if the toy car were pulled back an additional 10 centimeters? So 10 past that 8, 18 whole centimeters, what do you think would happen? So you'd say if the toy were pulled back an additional 10 centimeters, I predict it would go what? Go a shorter distance or a longer distance? The last question says, what evidence of balanced forces did you see? Remember, balanced forces mean that there are equal forces on that object, meaning there would be no motion. Okay, so when was there no motion, no movement? That's what you're going to write as your example. So go ahead and get started on your lab. Remember, if you don't have a car like this, find the video below where you will use my data. Have fun.